Yes, hello. Yes, hello. Assalamu alaikum. Now, beta, let me know if the voice is clear and the screen is also clear. Yes, okay. Now let's start the class. Today we are going to continue with the chapter Atomic Structure. This is your lecture number 21. First, we will have some recap of the old lessons or old topics which we have already done in midterm, and let's see what we have already done and then we will move forward. Okay, so please focus. Yes, at 11:20. Yes. Okay, so our chapter is atomic structure, and what we have learned till date, we have learned about the Dalton's atomic theory, then modern atomic theory, fundamental particles of atom, discovery of electron, proton and neutron, radioactivity. Then we have learned Rutherford's atomic model, atomic number and atomic mass. These all points or topics we have covered in midterm, and please be sure that till these topics your midterm exams will be conducted. Okay, now we are going to continue with the further topics that are isotopes, that will be included in your final term exams or in your final term studies. Okay, first we will have a short recap of the topics. Dalton's atomic theory, what we have learned in Dalton's atomic theory, that all matter is made up of atoms, or atoms are the indivisible and indestructible particles. All atoms of a given element are identical in mass and properties. Compounds are formed by a combination of two or more different kinds of atoms. I believe that you people have remembered or still learn the postulates of Dalton's atomic theory, and we are just recapping it. Okay, so next is a chemical reaction is a rearrangement of atoms. So I'm recapping it again. All matter is made up of atoms, so we define atom as indivisible and indestructible particle. All atoms of a given element are identical in mass and properties. Compounds are formed by a combination of two or more different kinds of atoms by a chemical reaction. So what is a chemical reaction? It is a rearrangement of atoms. It is a rearrangement of atoms. Now, what are fundamental particles of atoms? Fundamental particles of atoms are electrons, protons, and not neutrons. An atom is a complex organization. It is composed of even smaller particles called subatomic particles, right? These are electrons, protons, and neutrons. Here in this table is already given in your book and you must have gone through it. We have discussed it so many times. Here in the first column, the weight mass of the electron, proton, and neutrons are given in grams, then in kilograms, and AMU is the unit for mass or atomic mass or the mass number. And what are the charges on electron, proton, and neutrons? These are also shown here, that electron has negative charge, proton has positive charge, and neutron has no charge. That it means that neutrons are neutral. Next is radioactivity and Rutherford gold foil experiment. So radioactivity, can anybody tell me the definition of radioactivity? Yes, I believe that everyone has opened the book. You people have your books with you, chemistry books, page number 43. Please start writing the definition of radioactivity. What is radioactivity? Yes, yes, Fatma. Please start writing the definition of radioactivity. Hurry up. How do we define radioactivity? It is the spontaneous disintegration. What is the meaning of disintegration? breakdown. It is the spontaneous breakdown of the nucleus of an atom. Means when the nucleus of an atom spontaneously or suddenly breaks down, it emits some energy. That energy is called radio. That phenomena, that breakdown of the nucleus, is called radioactivity. That phenomena is called radioactivity, and the energy or radiations occur or that are emitted are differentiated into alpha, beta, and gamma particles, right? So, right, yes, in which invisible radiation. So, all those elements, all those substances which emit such kind of invisible radiation during the radioactivity process, they are called radioactive substances. In short, we can say all those elements or substances which emit radioactive particles are called radioactive substances, right? So here we are going to have a short recap of Rutherford Goldfoil experiment. Rutherford, he carried out so many series of experiments. In 1911, he carried out Goldfoil experiment, in which he described the properties of alpha, beta, and gamma particles, and especially the alpha particles, when he passed the alpha particles through a very thin foil of gold. And he proposed that the positive charge in the atom is concentrated in the center, means in the nucleus. And this was from the fact that the alpha particles, after collision with the heavenly particle nucleus, since nucleus is located in the center, it has positive charge due to the presence of proton. When he threw or when he passed the beam of alpha particles, the most of the rays, they passed straight away uh, outside the nucleus, but some of them were deflected to a some of them, a few of them deflected. When they come near to the nucleus, they deflected through a large angle or small angles, and very few of them, they bounced back. They did not fall or hit the nucleus because of the same particle, having same particles. Alpha particles are positively charged, and same is the charge of the nucleus, means both are the positively charged particles. That's why they repel each other. That's why the alpha particles, they bounce back rather to hit the nucleus or pass through it, right? Next is Rutherford atomic model. After carrying out certain experiments, he proposed that nucleus has two parts. Sorry, an atom has two parts: nucleus and the extranuclear part. We have gone through it several times. Okay, we have learned in detail each and everything. So I am going through it very quickly. That an atom is composed of protons and neutrons, means two particles which are residing in the nucleus are protons and neutrons, and outside the nucleus is the extranuclear part, where the electrons are revolved in their particular orbits, shells, or energy levels, right? Atomic number. How do we define atomic number? It is the number of proton in the nucleus of an atom, and we denoted it capital Z. The atomic number is actually the number of protons in the nucleus. Or here in the picture you can see that C is the capital C is the symbol for element carbon, and this 6, it means it is the number of proton in the carbon. It is also called atomic number. Atomic number, it is generally the number of protons in the nucleus. And mass number, it is also called atomic number. Please sorry, atomic mass, please remember it. Mass number or atomic mass, both are same, and they can be termed alternatively. So mass number, it is actually the number of protons plus number of neutrons in the nucleus. And the total sum of protons The total sum of protons and neutrons in the nucleus of an atom is called the mass number. It is denoted by A, capital A, right? Atomic number, it is denoted by capital Z or Z, and mass number or atomic mass, it is denoted by capital A. So number of neutrons plus number of protons in the nucleus, it is called mass number, and we also call it atomic mass. Understood? Is this clear? Class, quickly tell me if this is clear. Yes, Fauziya. Okay, right. Now let's move that what we are going to learn today. You people will be able to learn about the isotopes of different elements, and the applications of isotopes. Okay. Okay, now pay attention. What are isotopes? First, we will learn about the isotopes. Isotopes, we can define isotopes as the atoms of the same element having the same atomic number. We know that all the atoms in the element have the same atomic number, but their atomic masses are different. Look at the screen. Look at this picture. In this picture, they have shown us in the nucleus, protons and neutrons are present, and around the nucleus in the extranuclear part in the orbits, electrons are revolving. So we are discussing about the number of protons and neutrons. We know that the number of electrons are same in all the atoms. For example, we take example of chlorine here. That chlorine has the atomic mass 35 and its atomic number is 17 because there are 17 protons and 17 electrons. But in the nucleus, the number of neutron is more than proton. If the number of proton and the number of neutron are same, this is not isotope. If the number of neutrons are different, here the story revolves around only the number of neutrons. If the number of neutrons in the nucleus of an atom is more than the proton, then it is called the isotope of that element. That atom is called the isotope. For instance, chlorine has two isotopes, chlorine 35 and chlorine 37. Chlorine 37 has 17 electron and 17 proton. Number of protons and electrons would be same. Only the change is in the number of neutrons. Number of neutrons in chlorine 35, 18 neutrons, in chlorine 37, 20 neutrons. Right? So we can define atoms of the same element having the same atomic number, but their atomic masses are different, are called isotopes. Let's see the more examples of. Here are the example. This is the isotope of hydrogen. This is the isotope of hydrogen. We commonly know that hydrogen has one electron and one proton. If the atomic number or atomic mass means the mass number is 1, it means there is no neutron, only proton is present in the nucleus. If the mass number is changed and it becomes 2, it means there are 1 proton and 1 neutron. When we add them both, it becomes 2. So the mass number depends upon the number of protons and number of neutrons plus number of neutrons. Means when we add both the numbers of protons and neutrons, we get the mass number. If it is the number of proton is less than the number of neutron, it is called the isotope. Here another type of hydrogen, another isotope of hydrogen, that is called tritium. It has the mass number 3. Atomic number is same. Look, number of electron and number of proton both are 1. However, the number of neutrons are increasing. Here there is no neutron. Here in the second one, deuterium. This is called deuterium. This is called protium. Pro means 1. Protium. Deuterium. Deuterium means 2. Tritium. Tri means 3. So tritium has a mass number 3 because here the number of neutrons are increased. 1 proton and 2 neutrons. Then totally the nucleus contains 3 mass number. The mass number of the or the atomic mass of the nucleus is 3. So there are 3 different isotopes of hydrogen. 3 different types of hydrogen atoms are present. They exist in the universe. Next is the isotopes of different elements. Uranium. Uranium has the atomic number. Look at this subscript. This is the atomic number 92, 92, 92. But the number of neutrons are increasing. That's why their atomic mass or mass number are changed. One type of one isotope of uranium has the mass number 234, another one has 235, and the third one has 236. It shows that there are 3 different isotopes of uranium atom. Likewise, oxygen. Oxygen, yes, who is this? Please stop your. Abdul Rahman. Okay, so oxygen, the atomic number remains same. Atomic number of oxygen and all the isotopes of oxygen are remain same. 8, here again 8, here again 8. Only the number of the atomic mass or the mass numbers are changed due to the increasing number of neutrons in the nucleus. 16 means 8 protons and 16, 8 protons and 8 neutrons. 8 protons and 9 neutrons. 7 neutrons. 8 protons and 8 neutrons. Look here. Now the carbon atom, it also has 3 different types of isotopes. Carbon 12, carbon 13, and carbon 14. Number of proton, number of electron, and number of neutron in carbon 12. Number of proton are 6, electron 6, neutron 6. In carbon 13, number of protons 6, number of electrons 6, number of neutrons 7. Number of neutron is changed. Now again, it is here you need to do the correction. What could be the number? I have written it 6, but I want you people to let me know the correct answer here. What would be the number of neutrons if the mass number is 14? 6 protons, then what will be the number of neutrons so that it becomes 14? Please let me know quickly. 8. Yes. Anybody else? Is this correct? Yes. Abdul Rahman, yes. Bilal, right. Means when we add 6 plus 8, it would become 14. So here the answer, the correct number of neutrons would be 8. Right? So here this is correct. 7 plus 6, 13. And 6 plus 6, 12. So in this way, we also say that here the number of neutrons are 92. Number of if the 92 is the number of protons, then what would be the number of neutrons here in the uranium 234? Start writing the answers. You should minus 92 from 234. You will be getting the number of neutrons. Start subtracting a minus z. You will be getting the number of neutrons. 142, right? What about 235? Uranium 235. Uranium 235. What would be the correct answer? 143. And what about 236? Why everybody is not answering? Just 2-3 people are active. I want the participation from each and everyone. Abdul Ahad, Abdul Rahman is answering. Alicia, Eliza, Beta, I want the participation from everyone. Meda, Manahil, Nurulan, Roha, Rumesa. Yes, quickly let me know the Tabassum. Yes, Tabassum, I haven't got any answer from you. Shiza, Zoha, Zimal, please answer me. Yes, Hafsa, right, Meda, good. Yes, 236. Now start calculating about the oxygen. If 8 protons, total the mass number is 16 and the number of proton is 8. It would be, it's very simple, 8. What about the second isotope? Oxygen 17 and oxygen 18. Oxygen 17 and oxygen 18. Yes. Yes, right, right. Good. Okay, okay, beta. Now let's move to the next topic. Application of isotopes. Now we will learn that what are the fields in which we use isotopes. Radioactive isotopes have many useful applications in medicine. For example, cobalt 60. Cobalt is the name of the element. Its isotope is cobalt 60 is extensively employed as a radiation source to arrest the development of cancer. Means it is used to, cobalt 60 is used as a radiation or as a therapy for the treatment of cancer. Other radioactive isotopes are used as tracers for diagnostic purposes as well as in the research on metabolic processes. Right? In medical treatment, there are so many fields or so many different researches have been made on metabolic processes to use these radioactive isotopes as a tracers to carry out research for the treatment of different diseases, not only for cancer, for other diseases as well, like for the treatment of thyroid glands or treatments of kidneys, in the nuclear medicine, in the field of nuclear medicine or nuclear radiation. These radioactive isotopes have been used. There is one common way, the element tritium. Please write down element tritium. It is used for, I'm writing here in the chat box, element tritium. It is used, tritium is the, tritium is the isotope of, is the isotope of hydrogen, and it is used in the face faces of stop clock, sorry, wall clocks, faces of wall clocks, faces of wall clocks and wristwatches, because it glows at night, because it glows at night. Let me show you. We can see some it glows at night, and it has the power to, it has the power to glow at night. That's why it is used in the, it is used in the faces of wall clocks or wristwatches, so that these watches or wall clocks can be visible at night when it glows. So tritium is the, it is the isotope of hydrogen. I wanted to show you the pictures of the tritium when it is used as Just a minute. Please wait. I will be showing you through the. Yes, in this. Can you see my screen properly? Can you see this? Yes, let me know. Yes, okay. Here, this is the isotope of hydrogen tritium. This is called tritium, and it is used in the wristwatches or wall clocks so that they glow at night. Tritium, it is mostly used in high brand or high end watches so that the element it glows at night. This is called the tritium technology. It is used in different purposes, but most commonly it is used for because it is a self powered tritium technology, and it is used in so many different high end watches. Here you can see, you must have seen such type of watches people wear, and they glow at night. We have some alarm clocks as well, which at the night time they glow, and we will be easily see the time. We can see the time easily. So these tritium, this is called the tritium technology. What do we call it? Tritium technology. This is the isotope of hydrogen. Okay, got it? Let's move to our let's move to our lesson. Okay, where now let me know, please, class, if this up till here the application of isotope it is all clear. Please let me know if till here it is all clear, then we will move forward. Okay. So in short, I'm recapping it. In short, the isotope is actually when the number of neutrons are different than the number of protons in the nucleus. This is called the isotope of that element. Some atoms in the element, they have the same number of electrons, protons, and neutrons, but at times in some elements, number of neutrons in some atoms, number of neutrons are increased. This is called the isotope of that particular element. Right now, electronic configuration, it is the particular distribution of electrons among the different shells of an atom. Here I am just describing it. In our next lecture of atomic structure, we will conclude this chapter, and we will also learn that how the electrons are arranged in the different shells. Here you can see first shell holds 2 electrons, means the first shell, that is called the K shell. It comes just after the nucleus. This is called K shell. It holds only two electrons. Then the second shell holds 8 electrons. Right, if you remember, we have done this we have done electronic configuration, and the atomic structures we have drawn, and we learned that first shell should have the capacity of 2 electrons only. Second shell, it accommodates only 8 electrons, and the third shell, it holds and it accommodates only more than 8 electrons. Okay, section B, and yes, in 7th class, yes, section B, section A, and G, all three classes they have done the drawing of atomic structure and electronic configuration. Here in this class, we will only be drawing the table of the electronic configuration, but will not draw the atomic structure. Okay, so I think that it will be a bit easy only to make the table and to distribute the electrons in different shells. So how do we define electronic configuration? It is the particular distribution of electrons among the different shells of an atom, or it is the arrangement of electrons in the different shells of an atom. Now, please open your book on page number 50 to highlight or mark the important points. Yes, Abdul Rahman. Yes, it holds 18 electrons. Yes, good that you have remembered. Please highlight the important points. On page number 50. Atoms of the same element having the same atomic number but different atomic masses are called isotopes. For example, this whole para should be marked. If you have done, please let me know. Please let me know if you have marked it so that I will change the slide. Okay, done. Good. Page number 51. What are the names of the isotopes of hydrogen? They are protium, deuterium, and tritium. Protium has one proton and no neutron in the nucleus. Deuterium has one proton and one neutron in the nucleus. Tritium has one proton and two neutrons in the nucleus. Oxygen atom also has three isotopes having mass number 16, 17, and 18. Same is the case with carbon. Now, reinforcement questions. Here are different questions appear on the screen. Please start writing the answers. Define an atom. Quickly write down the definition of atom. Yes, I want participation from each and everyone. By the time I will mark your attendance. Yes. Okay, and atoms are the small particles. Yes, right, right. What about the second one? Define radioactive substances. Define radioactive substances. Beta carry positive charge. No, beta rays carry positive charge. No, this is wrong. Bilal, this is totally incorrect. Radioactive particles are of three types: alpha, beta, and gamma. Right? What are the charges on alpha, beta, and gamma? I am asking that. What are the charges on alpha, beta, and gamma rays? Yes, yes, Fatma, right. Charges. First, tell me the charge on alpha particles. Positive, Sania, right. Yes, Anita, right. Positive charge on alpha. Beta rays carry negative charge, and gamma rays carry gamma. What are the charges on gamma rays? What are the charges on gamma rays? Negative? Oh, Shiza, yes, good. Hamza, no. Yes, right, Hamza. Yes, gamma rays carry no charge. They are neutral. Radioactive substances, I was asking that to define the radioactive substances, but everyone, sorry to say, everyone was defining the radioactivity. Radioactive substances are those substances which emit invisible radiation. Okay, invisible radiation means invisible radiation, alpha, beta, and gamma rays. All those substances or elements which emit alpha, beta, and gamma rays or invisible radiation are called radioactive substances. What is the charge on the nucleus of an atom? What is the charge on the nucleus of an atom? Positive, yes. Yes, Anita, good. Right. Name two particles reside in the nucleus of an atom. Right, right. Is chemical reaction a rearrangement of atoms? Is this correct or incorrect? Yes, Anita. Yes, Anita, write down the answer. No, Shiza. Beta, chemical reaction is the rearrangement of atoms. True. Yes, true. Yes, Madar, Tabassum, good. In 1932, Henry Becquerel carried out gold foil experiment. Please do correction in this statement. Please do correction in this statement. Yes, I want the correction. Yes, good. Good, Laiba. Abdulahad, good. Zemal, yes. Okay, I'm writing one question in the chat box. Please answer it. My question is A minus Z is equals to, define the term. A minus Z is equals to question mark. I have put question mark. Please write down the term or what it defines you. A minus Z is equals to, is it atomic number or mass number? Zemal, I didn't get your answer. What does P stands for? What is the meaning of P? Atomic number, mass. Atomic number. Why everyone? Laiba, good. It shows the, yes, mass number. A minus Z. A minus Z. It shows, it is the mass number and it shows the number of neutron as well. A minus Z is equals to mass number. That is means the number of neutrons. Sorry, number of neutrons. A minus Z is equals to number of okay, beta. Yes. Okay, then it's time to say Allah Hafiz. Uh, your uh, your home assignment will be uploaded right after the class, and also I have posted the weekly quiz. I want you people to attempt it. Attempt it. Attempt the quiz, and in the next week we will be studying physics, kinematics of linear motion. Okay, okay, Nurran. Allah Hafiz. Allah Hafiz, everyone.